Welcome, curious minds, to another deep dive.
Great to be here.
Today, we're jumping right in with a phrase you've probably heard a million times. Garbage in is garbage out.
A classic. And so true.
Right. But when we talk about artificial intelligence, it's maybe more than just a saying. It feels like the absolute bedrock. Success or failure hinges on it.
It really does.
So, our mission today is to really explore why data preparation isn't just, important for AI. It's critical, absolutely fundamental. We want to unpack the concepts, the techniques, what actually makes AI tick for you.
That's the plan. And the sources we're looking at today, they really lay out a comprehensive guide here. They get right into the nitty-gritty of prepping data for AI.
Good.
And they bring up this often hidden problem right away, something that kind of silently torpedoes a lot of AI ambitions.
Data debt.
Data debt. Okay, that sounds heavy. Is it like having too many old files stored somewhere, or is it more complicated? Oh, it's much more insidious than that. Think of data debt as all the data-related problems piling up. Issues with quality, flexibility, governance, security. They just accumulate over time.
As companies change and grow.
Exactly. Organizations evolve, they merge, they collect all sorts of different data systems, different processes, and this debt just quietly grows in the background. It's a lot like technical debt, actually.
Ah, okay. I know that one. Like kicking the can down the road on software fixes for short-term gain.
Precisely. Ward Cunningham craned that back in '92. You defer costs, get something out faster, but you pay later.
Right.
But here's the weird thing, the paradox with data debt. Storage costs, they keep going down. But the cost of actually capturing information, accessing it, managing it, that just keeps climbing exponentially sometimes.
See?
And, the sheer scale of modern data, the famous V's of big data, volume, velocity, variety, critical veracity. How trustworthy is the data?
Right. Accuracy matters.
Immensely. And all those V's, they don't help with data debt. They actually make it much, much worse. Paying it down becomes this massive challenge.
So hold on. This isn't just an AI problem then, is it? This data debt thing sounds like it could cripple any organization, AI or not.
Oh, absolutely. The fallout from data debt is huge, way beyond AI. For starters, it just kills your ability to use analytics effectively. You can't get clear visibility across your systems if the data's a mess.
Yeah, scattered, inconsistent. You can't see the whole picture.
Exactly. And that directly slows down decision-making, makes operations clunky and inefficient. People waste time just trying to find or fix data.
I can imagine the frustration.
Totally. Plus, it opens you up to huge security risks, privacy issues, compliance nightmares. Keeping up with the regulations is way harder and more expensive when your data's all over the place.
Okay.
And beyond that, just finding the right data assets becomes a challenge. Building consistent data skills across the company. Forget it. Everyone's fighting their own little data fires.
So you're constantly paying interest on this debt, not just missed opportunities, but real money, right? What are some of those costs?
Well, think about the time and money just spent maintaining or maybe fixing duplicate systems, obsolete systems that people are scared to turn off.
Yeah, legacy stuff.
Right. Then add all the resources poured into cleaning data, managing it, integrating it, manipulating it across all these different, often incompatible systems.
It sounds exhausting.
It is. And you're paying for storage, licenses, infrastructure, for all these scattered, inefficient systems, too.
A constant drain.
And then there are the costs of fixing problems caused by the inconsistencies, data errors, system clashes, vendor lock-in issues. It goes on. And maintaining security and compliance across that fragmented landscape. It's a massive burden.
Okay, so what about the cloud? Doesn't moving to the cloud fix a lot of this? That's kind of the promise.
That's a really critical point our sources make. It's a common misconception. Moving to the cloud doesn't automatically wipe out data debt. Yeah. Without fixing the underlying data problems, the quality issues, the lack of governance, the cloud can sometimes just, multiply the problem. You might end up with more silos, just cloud-based ones, or new integration headaches.
So it's not a magic bullet. Shifting messy data to the cloud just gives you messy data in the cloud.
Pretty much. It can turn a simple migration into this ongoing complex mess if you haven't tackled the debt first.
Okay, that's a huge insight. So if just adding more tech, even cloud tech, isn't the answer, is this purely an IT thing to solve?
No, and that's another dangerous assumption. Viewing data debt as just IT's problem is a big mistake. It's an enterprise issue.
Okay.
Adding more tech often just means adding more systems, which can actually increase your debt over time. Our sources are really clear on this. The real solution is about process and method.
Process and method. Okay, so what does that actually look like? How do you start paying down this debt?
It means making a conscious shift, moving towards data architectures designed to consolidate systems, standardizing your data models, your methods.
Consistency is key.
Absolutely. Applying consistent techniques everywhere, on-prem, in the cloud, doesn't matter.
Yeah.
It also involves smarter ways to reuse data and maybe most importantly, continuous data governance, ongoing management, and transparency.
Right, not just a one-off project.
Exactly. It's a cultural shift. The basic idea is fewer systems are generally better, but you need more focus on architecture, on thoughtful design, on robust governance.
Yeah.
Especially because you can't predict the future.
Yeah.
Technology changes. You need resilience.
Building a solid foundation, not just constantly reacting. Makes sense. Okay, so we've got this picture of data debt, this kind of pervasive, silent problem. But people might still be thinking, all right, but what's the direct link to AI?
Well, here's the statistic that really connects the dots. You ready?
Lay it on me.
80% of AI projects are data engineering.
80%. Wow. Okay, that puts it in perspective.
Doesn't it? All that stuff we just talked about, data debt, quality, governance, it directly feeds into why so much effort in AI is spent just getting the data ready. It's the massive, often unseen chunk of the work before any fancy algorithms even get involved.
So that data engineering, what does that actually entail? Is it mostly about building like pathways for the data, for training and for real-world use?
Exactly. It's all about building robust data pipelines. Think of them as the lifeblood of AI. You need them for training the models, and you need them for when the models are actually out there doing their job, what we call inference.
Okay, let's break that down. Training data pipelines first. What's involved there?
Well, first step is just finding the relevant training data. And that can be anything, right? Unstructured stuff like images, video, text, audio.
Yeah.
Structured data from databases, spreadsheets, even semi-structured stuff like log files or JSON data.
So finding it all wherever it lives.
Right. Then figuring out if you need to collect more data and building pipelines for that collection. Then identifying what needs to be labeled or annotated. We'll definitely get more into that later. It's crucial.
Okay.
And a really big one, often missed, identifying and actively working to eliminate potential bias in your training set.
Yeah. You don't want the AI learning skewed or unfair patterns.
Exactly. You want fairness, accuracy, not just replicating existing biases hidden in the data.
Makes sense. And what about the other side? Inference data pipelines for when the AI is live.
Right. So for inference, you have to think about how the data is going to look in the real world. How will it actually come into the system to be used by the model?
Because it might be messier than the training data.
Often, yeah. So what steps are needed to prepare and clean that incoming real-world data? The goal is to make it match the format and quality of the training data as closely as possible.
Consistency again.
Always. And just like with training, you have to handle those V's of big data for inference too. The volume, velocity, variety, veracity. But now in real time, potentially.
Okay, so it's this continuous flow. Get the data right for training, then keep it right for inference. That brings us neatly to the actual toolkit, the nuts and bolts of data preparation for AI. How do our sources define this overall process?
They define data preparation pretty comprehensively. Basically, it's all the necessary activities you perform on data to get it ready for an analytics or machine learning project.
So everything we've kind of touched on.
Yeah, it includes cleaning, transformation, wrangling, augmentation, anonymization, usually all happening within some kind of data engineering pipeline. It's about making the data fit for purpose.
Okay, let's dig into some of those specific terms. Data ingestion and merging sounds like the starting point.
It is. Fundamentally, it's about getting the data out of its original source systems, moving it where it needs to go for processing, and then combining data from different sources, bringing all the raw pieces together.
Got it. And then data cleaning or cleansing. Sounds simple, but I bet it's not just hitting delete on duplicates.
Oh, definitely not. Cleaning is about getting the data into a truly usable, reliable state. Yes, deduping is part of it, but also removing extraneous data, bad data, irrelevant stuff, like maybe irrelevant background pixels in images or filler words in text data. It's also about reducing noise, information noise, visual noise, audio noise. And data anonymization is key if you're dealing with sensitive info.
Right, protecting privacy.
And a big part is often normalizing data, standardizing values across different ranges or scales. This makes training much more effective and efficient.
Making everything comparable. Okay, what about data splitting and selection?
This is about carefully dividing up your data set. You need different chunks for different ML tasks. The classic split is train validate, and test data.
Right?
And within selection, you've got filtering techniques. Two main ones mentioned are data sampling and data attribute pruning.
Okay, data sampling. You mentioned massive data sets earlier, petabytes. You can't train on all that, can you?
Usually not, and often you don't need to. If you have a truly enormous data set, data sampling is about picking a smaller, manageable subset that's still representative.
How do you ensure it's representative?
Well, it needs to be statistically significant, well-balanced, and crucially, unbiased. You want the sample to reflect the characteristics of the whole data set, just smaller. Gets you the insights without drowning in data volume.
Smart. And the other one, data attribute pruning.
That's about cutting out unnecessary columns or fields attributes, metadata from your data records. Stuff that just bloats the data set, adds noise, and makes training more complicated without actually adding any predictive value.
Trimming the fat, basically.
Exactly. Keep it lean, focused, and efficient.
Okay, next up, data transformation. Sounds like changing its shape or format.
That's the core idea. Changing data from one state to another. Could be format conversion, changing specific values or metadata, making it compatible with the system or model you're feeding it into.
Like in an ETL process, extract, transform, load.
Precisely. It's a key part of ETL when moving data into, say, a data warehouse, or when you're pulling data from a data lake for a specific analysis. It's all about molding the data into the desired state.
Got it. And finally, this one sounds cool. Data multiplication. Are we like cloning data?
Not exactly cloning, but it can feel a bit like magic sometimes. Data multiplication, or often called data augmentation, which we'll touch on more, is about strategically increasing the amount of useful training data you have by transforming and manipulating the data you do have. For images, think scaling, rotating, changing colors slightly, adding a bit of noise.
So the AI learns to recognize the subject under different conditions.
Exactly. For text, maybe paraphrasing or using synonyms, it's a technique you use when you just don't have enough diverse raw data to train your model effectively. You generate new, unique-ish training examples from your existing ones.
That's clever. A way to stretch limited data further. Are there, like, downsides? Can you overdo it?
You can, yeah. If the transformations are too extreme or unrealistic, they might actually confuse the model or introduce weird artifacts.
Wow.
But done right, it's incredibly powerful for making models more robust.
Okay, so that's the general toolkit. But you mentioned AI has some unique, really specific needs, which brings us to what our sources call the Achilles heel of AI, labeling and augmentation.
That's right. Beyond the general prep, AI often needs more specific enhancements, like adding extra necessary data, maybe some pre-calculated values, aggregating things, or even bringing in relevant third-party data.
Okay.
Filtering also becomes hypercritical, especially for explicitly trying to remove bias. You really have to scrutinize the data for hidden biases that could lead to unfair outcomes.
Right.
Feature engineering is another big one, creating new input features from existing data to help the model learn better. And maybe most critically for ongoing AI, having robust retraining pipelines. Models drift, data changes, you need to iterate.
Constantly updating the model. Okay, so data augmentation, again, what's the AI-specific angle here?
So data augmentation in the AI context really focuses on techniques to enrich the data specifically for machine learning. Especially for unstructured data, images, text, audio, video, often you need to add information or variations that weren't in the original data to help the machine generalize better.
Make it richer, more diverse for the AI. Got it. But then that Achilles heel, data labeling, why is that singled out as such a critical vulnerability?
Because so much of modern AI, especially supervised learning, relies on learning from examples. And those examples must have correct labels. The AI needs to be told, this image contains a cat, this text sentiment is positive, this audio is speech.
The ground truth.
Exactly. Without clean, accurate labels, the machine simply can't learn effectively. It doesn't know what it's supposed to be figuring out. And our sources really stress this. It critically requires human labor.
Humans are still essential teachers for AI.
For supervised learning, absolutely. Machines, well, they can't yet generate that ground truth for entirely new concepts on their own. They need us to provide the examples.
Fascinating. So what kinds of labeling are we talking about? Does it vary a lot?
Oh, hugely. You've got image and video annotation, unstructured text labeling, audio labeling, sensor fusion and point cloud labeling, even structured data labeling sometimes.
Okay, image and video, like drawing boxes around things.
Yeah, that's a common one.
Yeah.
Using bounding boxes or more complex polygons to tell the machine, this specific part of the image is what you should pay attention to. Could be shapes, lines, key points like on a face, often with descriptive text tags too, in 2D or even 3D.
And sensor fusion. That sounds like something out of sci-fi.
It's pretty cutting edge. Think autonomous vehicles. They use multiple sensors, LiDAR, radar, cameras, ultrasonic, all working together.
Right.
Sensor fusion is about the AI, learning from all the combined data simultaneously. These sensors often generate 3D point clouds, basically, digital maps of the world made of points. And labeling those to teach the AI about objects and distances in 3D space is incredibly complex.
Wow. Okay, so we get what labeling is and why it's vital. But it sounds incredibly time-consuming and detailed. How on earth do companies actually get all this labeled data?
That's the multi-million-dollar question. It is extremely labor-intensive. That's the core challenge. The sources lay out a few main paths.
Like what?
Well, you can try to do it yourself, build an in-house team, set up the tools, manage the quality control, but that takes serious time, resources, expertise.
Yeah, sounds expensive.
It can be. Or you can try to find datasets that are already labeled. Public datasets exist, but they might not fit your specific, unique needs.
All right. What else?
Another approach is getting your users to do it, sometimes without them even realizing it.
Wait, how?
Think about CAP-TCHA. There's select all images with traffic lights tests.
Yeah. Oh. Am I labeling data for free when I do that?
You might be. It's a clever way to crowdsource labeling for things like street sign recognition.
Wow. Mind blown. Okay, what are the more direct options?
You can hire a contractor workforce. Platforms like Amazon Mechanical Turk connect you with lots of people for microtasks like labeling. Or you can use offshore labor firms.
Okay.
Or you can contract with specialized third-party data labeling companies. These firms focus solely on providing high-quality labeled data as a service.
Professionals for hire.
Exactly.
Yeah.
And then, there are the other tricks people use, repurposing internal data that might already have some kind of implicit label, carefully harvesting data from online sources, if you trust it, leveraging those big public data sets like ImageNet or MNest or the classic academic solution.
Let me guess.
Grad students.
Yeah. Getting your grad students to do it. It's a time-honored tradition, apparently.
Love it. Okay, so after all this incredibly detailed, painstaking work, preparing, cleaning, augmenting, labeling, how do you actually know if the AI model you build is any good? If it'll work in the wild?
Right. That's the final crucial step, model validation. This whole process is about figuring out if your AI model has good generalization performance.
Meaning, does it work reliably on data it didn't see during its training? That's the real test. Can it apply what it learned to new, unseen situations?
Makes sense. And what are you trying to avoid here? What are the big failure modes?
The two big ones you're always guarding against are overfitting and underfitting.
Okay.
During the training process, you constantly validate the model using good quality data that you specifically set aside. You check if it's overfitting, meaning it got too specific to the training data. It basically memorized the examples, but can't generalize.
Like it aced the practice test, but fails the real exam.
Exactly. Or you check for underfitting where the model is too general. It didn't really learn enough from the training data to be useful. Validation tells you if you need to tune the model more to hit that sweet spot.
Finding that balance. Okay. And you use specific data sets for this, right? Ones kept separate from the main training batch?
Yes. Two key ones. First is the validation data set. This is a slice of your prepared data that you use during development to tune the model.
To check for that over-underfitting.
Right. To check accuracy, precision. See if it's overfitting or underfitting and guide how you adjust the model parameters. You might hold the set aside completely or use techniques like cross-validation where you rotate parts of the training data to serve as validation sets.
Okay, and then there's a final check.
Exactly. That's the test data set.
Yeah.
This is a completely separate chunk of prepared data. It's kept aside from both the training and the validation data, untouched.
The final exam.
Precisely. It's used after the model is trained and tuned as the ultimate unbiased measure of performance against data the model has genuinely never seen before. This holdout set, often around 20% of your prepared data, verifies its true generalization ability before you deploy it. It's the ultimate reality check.
Got it. Wow. So we really have come full circle, back to garbage in is garbage out. It's so clear now that successful AI isn't just about clever algorithms. It's fundamentally about this incredibly meticulous, often laborious preparation of data. We went from understanding that hidden burden of data debt all the way through cleaning, transforming, augmenting, labeling, validating. It really is a shortcut, hopefully for you listening, to grasp a core part of AI that maybe doesn't get enough attention.
Indeed. The real heavy lifting, the make or break stuff, often happens way before the AI even starts learning. It's all in the data.
And that brings us to our final provocative thought for you today. Given just how much human effort, how much detailed work goes into data prep and labeling, especially as data volumes just keep exploding, what happens next? What innovative approaches might emerge to scale this Achilles heel of AI? And how could that change how humans and AI work together in the future?
Definitely something to think about.
Something to mull over. Thanks for diving deep with us today.